think that'll work.
At this point, I've become very frustrated with what should have been a simple part of the project: rebuild the points and get the spark plugs firing. There was either excessive wear on the distributor or a manufacturing defect in the points that prevented the points from closing entirely,
The
possibly
temptation
both.
becomes to use like all the connectors.
Shut it past me. God, I hate that guy. I didn't feel good ordering another set of points because my research said that they were only manufactured in a very few places, and so there was no guarantee that I wouldn't just get another bad set. At this point, my frustration and the sunk cost fallacy convinced me to purchase an electronic ignition from Petronix. I had never used this style of retrofit ignition before, and they're definitely not a sponsor. The installation was crazy simple. It took me 2 minutes the afternoon the package arrived, 5 minutes if you include drilling a hole in the distributor housing, and yes, I used the old distributor. I'm prepared to force you to listen to an incredibly oversimplified explanation of the system as an apology for not shooting any footage of the install, while that guy does random stuff in the background. Mechanical points ignition operates by having a cam with one lobe per cylinder on the distributor shaft. The points ride on this cam, which opens the points as they ride up the lobe and closes them as they ride down. The coil builds up a charge while the points are open and discharges when they close, but it doesn't discharge straight to ground, but rather across the gap of the spark plug. This creates the spark that ignites the mixture in an individual cylinder. The Petronix ignition works by mounting a plastic ring containing magnets, one magnet per cylinder, on the cam lobe of the distributor. The magnets now play the role of the lobes. A Hall effect sensor mounts in place of the points, with a small gap between the magnet ring and the sensor. The sensor now plays the part of the mechanical points. As the distributor shaft rotates and each magnet of the ring passes the sensor, this grounds out the coil just like the closing of the points would do. The Petronix installation was crazy simple. It took me 2 minutes the afternoon the package arrived, 5 minutes if you include drilling a hole in the distributor housing, and yes, I used the same old distributor. Which brings us back to what's happening here. I have helpfully installed the Petronix ignition off camera, and am once again rethinking my hack job of a wiring harness. This won't be the last time. The new electronic ignition is in place and eliminates the issue of bad points or worn distributor lobes. All the old parts of the system have been checked and rechecked, so I guess nothing else can go wrong, right?
Key goes on, emitter needle moves, so I'm just going to do a quick test. Key on, hit the button, check for spark. Then I'll check voltages. No spark. It's a pretty big gap for it to jump though, but it should be able to do it no problem. No spark on number 4. Let's check another one. Let's check number 2. It's not going to fire off anyways because there's no fuel, no starter fluid, no nothing. I don't see any spark. Alright, off.
The palpable frustration you see here has to do with the fact that I've now doubled the investment in this
Voltages.
project and still not running.
Let's close this up so I don't kick it, knock it over. As is my wont. Now it's closed, so I'll just step on it and break it. All that work, I am no farther along than I was before.
Well, it does crank. Didn't do that either when you got it.
Voltages. So I need my high resistance test lead. So testing to the top of the coil. Testing the top of the coil. Key on, 6 volts. Oh, top of the coil, because it goes to the ballast resistor. That tells me that the coil or the ballast resistor is getting power. Everything's getting what it should. We're just not firing. Okay, troubleshooting the Pertronix electronic ignition. The instructions say this should be a go, no-go system. It should just work. It is super simple. So I think the first thing I'm going to do is pull this apart and make sure that I have not overheated the igniter, which is the only warning thing they have, and the only real test for whether or not you've overheated the igniter is if the label is wrinkled up, like it's been heat treated. If I can baseline this so that I know that it's hooked up properly, and then I can move forward. This is my rule, and my kids are tired of hearing it. When you run into a problem, you keep going backwards. Keep going back to basics to eliminate all the possible issues. That's what I'm doing. On the side over there, the bolts are kind of blocked by the... Alright. There's the distributor and coil, the unit. You can put the gaskets on these things, and man, they become kind of hard to take apart. I don't like how that gasket's at in there. So let's pull the coil for a minute. It's because I've had to reseat the coil a couple of times. And it's okay. Just that proud, that's all. I'm pretty sure that connection, that's the connection that they always say is what goes bad. This spring down to that connection at the top. But I see marks in that, so it looks like the spring was making contact. And I don't see why it wouldn't be. It just happens to be the number one thing they say. So, the cap. There's the rotor. I don't know if this is even necessary with the electronic ignition. This is a piece to keep moisture, any moisture that might come in there from affecting the cap. Without removing that, I'm going to say that looks fine. It looks like it did when it was installed. It's coming off a little bit, but it looks correct. A lot of this video is going to be me reading the troubleshooting stuff off the interweb. Voltage and resistance testing. Okay, so the first is to test the maximum resistance from the igniter plates to the negative battery terminals, 2 ohms. After installing the igniter module and distributor, and with the distributor on the engine, use a digital multimeter to measure the resistance from the aluminum plate holding the module to battery minus. The net resistance, actually the net resistance, Must be less than 0.2 ohms. I mean, it bolts to the block. I'm not grounded to the block, I'm grounded to the frame. So there are potential issues there, but let's, of course they want this bolted to the block. And if I test any other way, then I'm kind of shorting it. Okay. I am done fooling with this. Take the leads off and I'll reinstall the leads as needed. I left all the wires long so that once I get everything corrected, then I can install the wiring harness to length, because I've run into too many problems in the past where the problem involves moving something and now I don't have enough room in my wiring. So I like to leave all the wires long. Normally I would just do a jumper to the block, test it that way, but then if I get a bad value, what's the problem? Is it in my test leads or is it in the actual block? Is the resistance actually bad? So what I'm going to do here is put this in place. Let's see. I appreciate Ford doing this, but you can only time it. You can't mess up the timing between the distributor block and the distributor, because it only goes in one way. There. Alright, I'm going to run one bolt in, test it, and if it tests bad, then I'll run the other bolt in and retest. And you guys get to watch me run a bolt in. First, we will test the resistance of the test leads. That is not right. I'm getting like 20 kilo ohms. So I'm using this little test lead here. This appears to be what's introducing me most resistance. This is just a really convenient way for me to clip on and not have to worry about holding this in two different locations. By using that lead, I can clip on automatically, but I just had to upgrade the wiring. I was using this to excite the solenoid, and it stopped working. And now I know why, because I guess this wire got overheated or something, because its resistance has gone way up. So, not going to do that. Yeah, see that? Well, that's 0.7. 0.7 ohm. And touch the two together, and you still get some resistance, 0.3. But if that's 0.7, then when I touch up there, well, this with the test lead, yeah, it's 0.7, so it shouldn't be more than 0.9 if I test to the block. So that's there, and let's test right to the body. Should be, can you see that? It's 0.7, 0.6, 0.7, which is the resistance of the test lead, right? So now 0.8, 0.9 should be the maximum resistance to ground. I get 0.6. Ground is good. That much is good. I don't need to run the second bolt in. Next test. The voltage test. Do not disconnect wires from the ignition coil. So this is going to be difficult because the coil wants to sit on top. We'll see. Hang on. So the steps. Place the ignition switch in the off position. It's conveniently off position because the wiring for it's not hooked up. Connect the jumper wire from negative terminal of the coil to a good engine ground. So this is the coil, the Ford coil. I'm assuming negative is this, because this would be the positive. although it could be that. No, that's the output to the distributor, which comes to the cap, which then distributes the spark. So that's the output of the coil. Right. The reason I had that weird lump in my gasket is the gasket was 2 degrees out of square. Okay. Getting distracted. So I need to figure out what the negative is. That seems like a weird thing to do. Connect the voltmeter red lead to the positive terminal of the coil and the black lead to a good engine ground. Turn the ignition switch to the on position and note the voltage reading on the voltmeter. Quickly read the voltage and turn the ignition off. Leaving the ignition on for an extended period could result in permanent damage to the igniter, which is what I'm concerned has happened here. So it says I should be getting 8 volts. This is checking the coil. And so this is set up for a 2-post. When you have an external coil and you have 2 posts on it, and 1 post, yeah, that won't work with this coil. So I can't follow that test through, unfortunately. Alright, I'm going to put you guys on hold. I'm going to reinstall all the stuff and see if I can... I'm going to test to this lead, which is the other side of the coil, and make sure that this thing is getting a charge. I'm also going to... This is an Australian site, but it has better directions than the no directions I got. So I'm going to re-follow all of the instructions here. Okay. Alright, I'm putting you to sleep. Okay. Still troubleshooting the Pertronics installation. So thanks to Ken Harris for finally outlining a test procedure for the igniter. This is the core piece. It's the igniter for the ignition. It's a Hall effect sensor. This has magnets in it. This fits over the shaft of the distributor where the ramps were, which used to open and close the points. This replaces that by just having 4 or 6 or 8 magnets, depending on what you have. This is a 4-cylinder, which stimulate the Hall effect sensor every time it goes past. So your voltage should drop from battery voltage to 0 back to battery voltage again. That's what fires the coil and fires your ignition. So this is a test rig for that. It's a little bit odd. The ignition plate that the igniter is mounted to is set to battery ground. The ignition red wire, which is this wire that feeds out of the distributor, in this case, this is for a Ford 9N, hopefully, is connected to battery positive and the red lead on the voltmeter. You don't want to leave it hooked up too much because these do heat sink. If they stay at 12 volt for too long, they'll overheat. They're supposed to flash on and off. So the black ignition wire, which in this case is the wire that used to go up here and connect to the condenser, it's also the ground for the coil, where the coil grounds out to. That's connected to the voltage meter black lead. That's really it. So plate to battery ground, igniter red to battery hot, and voltmeter red lead, igniter black to voltmeter ground. So what we should see as we rotate the shaft of the distributor is we should see this go from 12 to 0 to 12 to 0 4 times per cycle. So there we have 12, rotating it slowly, goes to 0 or thereabouts. Keep going, back to 12, to 0 at about 180 degrees. Keep going to 12, to 270, it'll go to 0 again. Then it goes back up to 12, back where we were to 0. So, this unit is functional. It is something else I'm doing. Now I've installed an aftermarket, distributor cap and rotor. It's the original distributor. I've made new wires, so I'm going to wring out all the wires. I can't really test the coil so much. I can try to test as the rotor passes each pole that I get something, but I don't want to hook to coil power because that'll blow my meter up. So at that point, it concludes this test. I'm back to square one. Everything seems to work properly. I'm just not getting a spark. Same test as before, but in place. So the negative is wired, negative of the voltmeter is wired to the negative of the distributor cap. Let's see with the ground removed down there. I don't know. See? Set this back without shorting the starter out. Okay, so that's there. And then the positive goes to the same feed back here on the back of the ammeter that the Pertronics unit gets its power from. And we're going to use test light because that's the best way to see it. You can see it on the digital voltmeter, but it fluctuates too much. So we put the power back there. I don't know if you can see the key switch on, get 12 volts, start to crank the motor. Test light flashes. That indicates that the Pertronics unit is functioning. For some reason though, the coil is not grounding out. So that's what I'm struggling with right now. I know I should be recording the whole process live, but to be honest, a large part of the process is me staring off into space, thinking about stuff, drinking coffee. Kind of like that. Okay, so here we are at the business end, the distributor in place. We've proven that the Pertronics unit is in fact firing. So, the thing to test is on the coil, is this making contact at the same place that the green negative wire is now going, and is this front lead making contact with the distributor cap? I suspect one of those two things is not happening correctly. The way to test it is to install it and do the same test except to the top of the coil, and you should see the coil ground out 4 times a cycle. Get the same blinky test light situation, and I never see that. I only ever see a solid coil, a solid 12 volts to the coil. Never fluctuates. It looks like it all lines up, but we're dealing with stuff made, yeah. I'm not going to get on a high horse about this. I'm really frustrated. This is like day 3 of me tinkering with this to try to figure it out. I don't think a points problem has ever taken me this long before. We're down to everything that's here is functioning. The coil is a simple thing. I can't believe that this coil is not triggering properly. That just seems crazy. But on the other hand, I have another 12 volt coil in the garage, and the smart thing to do here would be to swap it out and see if that fixes the problem. Notice I said that would be the smart thing to do. Yeah, alright, so I guess we're down to that. All right, after all of that, I swapped out to the old 12 volt coil with 2.6 ohms of internal resistance that I found in the broken toolbox in the back of this thing. I took out my brand new coil that I just bought that measured 2.8 ohms of internal resistance that was not triggering. So this is what the real trigger test looks like. Just a test light hooked up to the top of the coil. Turn it on, it's 12 volts. You hit the button, that's firing the spark plugs. I can tell without even hooking up the spark plug tester because I don't have to. The next step is to feed it some ether and see what it does. Ignition on. Woohoo! It runs. Cough. Anyways. Alright. I guess I gotta put the fuel and cooling systems back together again now. Which I really should record, but